Have you ever wondered why some clouds produce rain, while others bless us with intricate, delicate snowflakes? The journey from a tiny water vapor molecule to a beautiful, frozen crystal is a marvel of atmospheric physics. The Bergeron process, also known as the Bergeron process, is the primary mechanism responsible for snow and ice crystal growth in cold clouds, particularly those with temperatures below freezing. It explains how ice crystals can grow rapidly at the expense of supercooled water droplets, eventually becoming large enough to fall as precipitation. The fundamental principle behind the Bergeron process lies in a unique atmospheric property. At the same temperature, the saturation vapor pressure over ice is lower than the saturation vapor pressure over liquid water. This means that in a cloud where both supercooled water droplets and ice crystals coexist, there is always more moisture available in the air than the ice crystals need to stay saturated, but less moisture than the liquid water droplets need. Consequently, water vapor molecules preferentially deposit onto the ice crystals, causing them to grow, while the supercooled water droplets, unable to compete for the dwindling water vapor, begin to evaporate. This continuous transfer of water vapor from liquid droplets to ice crystals drives the rapid growth of the ice crystals, which can then collide with other supercooled droplets, freezing them on contact or aggregate with other ice crystals to form snowflakes. Understanding this process helps scientists predict when and where snow will form, as it requires very specific atmospheric conditions. For the Bergeron process to be effective, clouds must contain a mix of supercooled water droplets, which are liquid water droplets that remains unfrozen at temperatures below 0 degrees Celsius, and a smaller number of ice nuclei, which are tiny particles that act as templates for ice crystal formation. This ingenious natural process is so efficient that it is often referred to as a cold rain process, because even in clouds producing rain, the precipitation often starts as ice crystals aloft that melt before reaching the ground. The presence of even a small number of ice nuclei is critical. Without them, clouds might remain rich in supercooled water but fail to produce precipitation. In essence, the Bergeron process beautifully illustrates how subtle differences in physical properties at the microscale within a cloud can orchestrate the majestic formation of snow, profoundly influencing global weather patterns and the water cycle.
If you love learning about water, like, subscribe, and keep exploring with us.